When using metal boxes for switches in a sheetrock wall, the screws themselves serve as an acceptable grounding means. This relies on the electrical continuity established between the switch, the metal box, and the grounding conductor within the electrical system. The National Electrical Code, or NEC, provides guidelines for ensuring safe and effective grounding practices. According to the NEC, equipment grounding is essential for minimizing electrical shock hazards and providing a low impedance path for fault current to return to the source. This low impedance path facilitates the operation of overcurrent protective devices, such as circuit breakers or fuses, which interrupt the flow of electricity in the event of a fault. Grounding ensures that metal parts of electrical equipment, which could become energized due to a fault, are maintained at or near ground potential. This minimizes the risk of electric shock if a person comes into contact with the energized metal. The grounding conductor, typically a green or bare copper wire, connects the metal box to the electrical system's grounding point, which is usually the neutral busbar in the electrical panel and, ultimately, to earth. When a switch is mounted in a metal box, the metal mounting screws provide a direct electrical connection between the switch's metal frame and the metal box. This connection effectively grounds the switch, provided that the metal box is itself properly grounded. The effectiveness of this grounding method depends on several factors. Firstly, the metal box must be securely connected to the grounding conductor. This can be achieved by using a grounding clip, a grounding screw, or a grounding wire connected to the box with an approved connector. Secondly, the mounting screws must make good electrical contact with both the switch's metal frame and the metal box. This requires that the screws are tightened adequately and that the surfaces are clean and free from corrosion or paint. Thirdly, the metal box must be properly bonded to other metal components in the electrical system, such as metal conduit or other metal boxes. This bonding ensures that all metal parts are at the same electrical potential, minimizing the risk of voltage differences and shock hazards. The NEC specifies the requirements for bonding metal components in Article 250. Typically, bonding is achieved by using bonding jumpers, which are short lengths of wire that connect the metal components together. These jumpers are typically made of copper and are sized according to the ampacity of the circuit. While the screws can serve as a grounding means, it's crucial to verify the integrity of the grounding connection. It is generally best practice to use a grounding tail, also known as a pigtail, especially in situations where the electrical connections might be subject to vibration, corrosion, or other factors that could compromise the integrity of the screw connection. A grounding tail is a short length of wire that is connected to the metal box using a grounding screw or clip and then connected to the grounding screw on the switch. This provides a dedicated grounding path that is independent of the mounting screws, which increases the reliability and safety of the grounding system. The NEC also requires the use of listed or approved grounding devices and methods. Listed devices have been tested and certified by a recognized testing laboratory such as Underwriters Laboratories, or all, to meet specific safety standards. Approved methods are those that are acceptable to the local electrical inspector or authority having jurisdiction, or OJ. Using listed devices and approved methods helps to ensure that the electrical installation is safe and compliant with the NEC. In summary, while the screws can provide a grounding means for switches in metal boxes, it is important to ensure that the metal box is properly grounded, that the screws are making good electrical contact, and that the electrical system is properly bonded. It is best practice to use a grounding tail to provide a dedicated grounding path and to comply with the NEC. Always consult with a qualified electrician if you have any questions or concerns about electrical grounding. They can assess the specific conditions of the electrical system and recommend the best grounding methods for the application. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock hazards. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working on electrical equipment, it is best to hire a qualified electrician to do the work. Grounding is a critical aspect of electrical safety. It is important to understand the principles of grounding and to follow the requirements of the NEC to ensure that electrical systems are safe and reliable. A properly grounded electrical system helps to minimize the risk of electrical shock hazards and protects people and property from electrical fires. It is also important to periodically inspect the grounding system to ensure that it is functioning properly. Look for signs of corrosion or damage to the grounding conductors or connections. If you find any problems, have them repaired by a qualified electrician as soon as possible. The grounding system is an essential safety feature of any electrical installation. By understanding the principles of grounding and following the requirements of the NEC, you can help to ensure that your electrical system is safe and reliable. Some additional information to consider includes the size of the grounding conductor. The NEC specifies the minimum size of the grounding conductor based on the ampacity of the circuit. The grounding conductor must be large enough to safely carry the maximum fault current that could occur in the circuit. The NEC also specifies the type of grounding conductor that must be used. Typically, a copper or aluminum conductor is used. The grounding conductor must be insulated if it is installed in a wet or damp location. Another important consideration is the grounding electrode system. The grounding electrode system is the connection to earth that provides a reference point for the electrical system. The NEC specifies the requirements for the grounding electrode system in Article 250. Typically, the grounding electrode system consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode system must be properly installed and maintained to ensure that it provides a reliable connection to earth. The NEC also addresses the grounding of specific types of equipment, such as motors, transformers, and generators. The grounding requirements for these types of equipment may be different from the grounding requirements for general-purpose circuits. It is important to consult the NEC for the specific grounding requirements for each type of equipment. In addition to the NEC, there may be local electrical codes or regulations that apply to electrical installations. It is important to be aware of and comply with all applicable codes and regulations. Electrical codes and regulations are designed to protect people and property from electrical hazards. By following these codes and regulations, you can help to ensure that your electrical system is safe and reliable. Grounding is a complex topic, and it is important to have a thorough understanding of the principles of grounding and the requirements of the NEC. If you have any questions or concerns about electrical grounding, it is best to consult with a qualified electrician. They can provide expert advice and ensure that your electrical system is properly grounded. Keep in mind that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock hazards. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working on electrical equipment, it is best to hire a qualified electrician to do the work. They have the knowledge and experience to safely and effectively perform electrical work. Furthermore, consider the environment where the electrical system is installed. In corrosive environments, special precautions may be necessary to protect the grounding conductors and connections from corrosion. The NEC provides guidelines for grounding in corrosive environments. It's also wise to think about the potential for electromagnetic interference, or EMI. Proper grounding can help to reduce EMI, which can interfere with the operation of electronic equipment. The NEC addresses the grounding of electronic equipment in Article 647. It is worth noting that there are different types of grounding systems, such as grounded systems and ungrounded systems. Grounded systems have a neutral conductor that is connected to earth, while ungrounded systems do not. The choice of grounding system depends on the specific application and the requirements of the NEC. The selection of overcurrent protection devices is also related to grounding. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. The proper selection and coordination of overcurrent protection devices are essential for ensuring the safety of the electrical system. In conclusion, understanding electrical grounding requires a comprehensive approach, encompassing the selection of materials, installation methods, and adherence to the NEC and local codes. Consulting with qualified electricians and staying informed about the latest electrical safety practices are crucial for maintaining safe and reliable electrical systems.